Second salvo, 200 yards short. Third salvo, on target.
Long before Pearl Harbor, the Signal Corps of the United States Army knew it would take more than a telephone wire to connect this voice with all the other fighting units that had to hear it. They knew it would take radio transmission. Radio can reach these tanks wherever they are and tell them what's ahead. A radio transmitter could coordinate the movement of troops, bring tanks and infantry together at the right place at the right time. But it would have to be a mobile radio transmitter. And it would have to be a powerful transmitter to keep an unbroken contact between our forces on the ground, in the air, and on the sea. The control of widely separated forces, the timing of their action, the success of the attack depends upon reliable radio communication. Yes, the Signal Corps engineers knew just what kind of a transmitter it would take to do the job. But the big problem was to locate a manufactured transmitter of a design that would come close to these requirements. In this pre-war Hallicrafters HT-4 transmitter, the Signal Corps found many of the answers. It was designed especially for amateur use. It was easily capable of worldwide communication using either code or voice. Another great advantage was the fact that this Hallicrafters unit had been on the market for several years. There was an opportunity to check its performance through the records of hundreds of America's hams. And these amateurs know good performance. It employed band switching in the exciter and driver stages, which made it possible to change frequencies very rapidly.
Say W2 USA, W4 GWZ calling 20. I'm sorry, I have to interrupt. 4G George, repeating me now, W2 USA. The center of the traffic is hello 20, hello 20, back to you, or if you stand by, because I'm out in the control room making a station break. I wonder if you're still receiving the red station, and I'll read too fast. Calling 20, otherwise, calling any 20, calling any, I'm sure that you're hearing me. But I would like to...
Hello, CQ. Hello, CQ. This is W9WZE Chicago, W9WZE Chicago, calling CQ for any 20-meter phone and standing by. Go ahead, please.
Okay, just a...
Hello, W9WZE Chicago. Hello, W9WZE Chicago. This is W6QD, Los Angeles, California. W6QD, Los Angeles, calling W9WZE Chicago. Go ahead, Bill.
Hello, W6QD, Los Angeles, California. This is W9WZE Chicago coming back. Good evening, Herb. Your signals are coming in fine tonight. R5S9. By the way, Herb, what are you doing on 20-meter phone? I thought you always worked CW. Now let's hear something about that marvelous California weather, eh?
Alaska, Australia, Europe, South Africa. These were regular, almost daily experiences in many amateurs' homes, where Hallicrafters were rapidly shrinking this old world of ours. The transmitter that serves the Army must be able to perform anywhere and under all kinds of unpredictable conditions. Up to this time, no one had ever thought seriously of putting this sensitive, finely balanced instrument on wheels and bouncing it around foxholes. What about vibration? Where would the power come from? The job of toughening up the HT-4 to go to war fell on the shoulders of Bill Halligan, Bob Samuelson, Hallicrafters chief engineer, and the hard-pressed technicians of the Signal Corps. There were few changes needed to adapt this unit to Army needs. There was good engineering and good sound construction in the set to start with. This was to be the new home for Hallicrafters equipment. Everything needed to transmit and receive had to be packed into this small space. That would take some more good engineering. This demand was nothing new to these pioneers. There are no fixed limits in Hallicrafters design or construction. There is always development, change, improvement. Many of the war adaptations were drawn from advanced developments that had been in the experimental stage for months. For example, in the pre-war model, plugging in a tuning unit might be quite a trick if the holes in the prongs couldn't get together. For the new Signal Corps transmitter, guide channels made this tuning unit change quick, positive, and held the unit securely in place. In the pre-war model, the prongs on the tube were enough to hold it in place. But this won't do for hopping shell holes. A tube support or ring was added to lock the tube firmly in position so that no amount of bumping or vibration would move it. For stationary use, no special footing was needed to anchor the transmitter. But for rough riding in a truck, rubber shock-proof mountings were added. In the process of making the entire unit more rugged, this air padder was replaced by a new vacuum tube padding condenser. Rooftop antennas could be as large as the pre-war ham wanted to make them, but it was pretty obvious that a rigging such as this one would hardly do on the top of a Signal Corps truck. The solution was in the use of whip antennas and in designing an antenna tuning unit which would efficiently transfer the output of the transmitter to the whip antenna. Throughout all of these changes, to adapt a peacetime transmitter to wartime requirements, the high-quality standards of Hallicrafters were strictly maintained in workmanship, in design and construction, and especially in performance. When the Signal Corps inspected the first of Hallicrafters transmitters armored for war, they found what they were looking for: a high-powered unit that had been made completely mobile, one that delivered good, reliable performance under all conditions. The first big job had been done well. Then came the warning of another, bigger job. Field reports indicate performance of SCR-299 exceeds expectation. Request you expedite production as much as possible. And in working man's English, that means let's go on production. This is the plant in Clearing, Illinois, where mass production of the new SCR-299 mobile radio station was obtained on a scale never dreamed of before in this industry. The key men for this tremendous production job were selected from the ranks of the American radio amateurs. These men had the know-how, the technical background and experience it took to get into action fast. This entire operation is headed by Herb Hartley, known to the amateur fraternity as W9WNG. This production was accomplished through the splendid cooperation of hundreds of loyal, skilled workers who realized how big the job ahead was and knew how to do it. It was achieved through the unfailing efforts of many suppliers and their thousands of workers who built the tubes, the transformers, the condensers, coils, insulators, the steel chassis, and all the other components that go in to make the SCR 299. And finally, the very design and construction of the transmitter lent itself to mass production better than any other pre-war domestic transmitter. The chassis was strong. There was room to work with sub-assemblies. This is the main assembly line, from the end of which come the completed transmitters. This is the feeder table for the main assembly line. Here the sub-assemblies are inspected or hooked up to other components. At the foot of the main assembly line, the transmitter looks like this: a steel base to which are added sockets for rectifier tubes. Then the bleeder resistor, which furnishes a constant load on the high voltage supply. Next, the filter choke and condensers, which supply direct current to the plate circuits of the transmitter. In wiring these parts, a great deal of time and work is saved by the use of pre-formed cables. The cables are cut, formed, and tipped, all ready for installation. And here's the base assembly, completed in just a little more time than it's taken to show it. Meanwhile, on the opposite side of the table, the power control panel is being assembled. These are the controls for filament voltage and modulator bias. The purpose of this panel is to group, within convenient reach of the operator, all the essential power controls. These cables here are cut to length and form over on the feeder table. Terminal lugs are soldered to the ends. Then all the other wires needed in the circuit are placed into position, bound together, so that soldering to terminals is the only operation needed in the final assembly. This is the power panel cable. When wiring is completed and the switches and fuses have been installed, the sides are joined to the power control panel, and this unit is ready to join the main assembly line. The transmitter begins to take shape as the base is joined to the power panel unit. Electric hoists are used for ease and accuracy in handling these parts. Now the main power transformer is set in place. This is the unit that steps up the input to the high voltage required to operate the final amplifier and modulator tubes. After the transformer is connected, the entire deck or base is hoisted to a dolly to make handling easier. There's high power equipment on this deck, and it's heavy. The second deck contains the audio driver stage and modulator of the transmitter, which makes possible radio telephone operation. This entire unit, built in another plant, has been inspected on the feeder table and requires only a modulation transformer and the phone CW relay to be complete. The top deck of the transmitter, the radio frequency section, begins with the installation of the exciter assembly, which is fabricated at Hallicrafters 26th Street plant. 3 separate tuning units may be plugged into this assembly, any one of which may be selected by the band switch. The panel is joined to the frame so that shafts and controls can be properly placed. This is the extension shaft to the band switch. By the use of this band switch connected to the exciter and driver stages, it's possible to change frequencies very rapidly. That's vitally important in military operation. The final amplifier tuning condenser assembly was built as a unit on the feeder table. It is placed carefully in position. Before this radio frequency deck joins the main assembly line, the standoffs are added. The exciter to modulator cable is hooked up. The neutralizing condenser is mounted on the standoffs. The main tube socket is added. Here are the antenna binding posts through which passes the output of the transmitter. This unit is now carefully inspected before it moves into main assembly. Every element, no matter how large or small, is inspected and tested before it goes into a transmitter. When the radio frequency deck joins the main assembly here, the big job is nearly done. A steady flow of finished units has been made possible by intelligent planning of the work at all Hallicrafters plants, perfect coordination with the suppliers and subcontractors, and hundreds of skilled and tireless hands. Now the relays are covered. The smaller tubes are set in place, and the completed unit is ready to leave the assembly line. The transmitter is now ready for the first of many tests it will receive before it earns the stamp of final approval. This is the electrical testing room, where the transmitter's output, modulation, and keying are accurately measured and recorded. This work calls for plenty of technical skill and knowledge, so the staff here is principally made up of experienced radio amateurs. Signal Corps inspectors watch closely these important steps in controlling both the quality and performance of the transmitter. This test measures the radio frequency output of the transmitter. Instead of allowing the signal to radiate over an antenna, these bulbs, called the dummy antenna, convert the RF output into heat. Another important test is the one made for overload. The purpose of this is to make sure the relays respond properly to protect the circuits. This is also done to determine the capacity of the entire transmitter to absorb a temporary overload in normal operation without breaking down. Next, the transmitter is given a trial at sending code signals. When operated in this manner, the audio amplifier and modulator are not used. The flashing of these rectifier tubes shows how the key simply makes and breaks the output to form the characters of the telegraph code. To check how well the transmitter responds to all essential voice frequencies, the oscillograph is used. This detects any distortion and locates at what point the distortion occurs. This transmitter shows a normal frequency response. When the lid goes on the transmitter, that means it has passed all the electrical tests with an A1 rating. It's ready now for the Signal Corps truck. In another part of the plant, radio receivers are being mounted on a table assembly that makes up the listening end of this communication unit. Each table is equipped with two similar radio receivers. One operates on the main power supply and the other from an auxiliary battery. The entire assembly is tested for proper operation as a unit. The two receivers can be operated simultaneously. This is the speech amplifier. Two separate operating positions are provided. Part of the table assembly includes two loudspeakers, two field telephone instruments, and a portable typewriter. This is the final step in assembly, bringing the transmitter, the receivers, and the accessories together and installing them in the truck. Once the equipment is mounted inside this door, it becomes officially the SCR-299. It's on the way to the front. Easy does it. There's no room to spare here, and there's plenty more to be put in. Every inch of space is accounted for in this truck, and these men know how to use it. A place for everything, and everything goes right into place quickly and securely. While the transmitter is being bolted to the floor, the table assembly with its receiving equipment moves in. Accuracy in design and construction makes it possible to save many valuable hours throughout the entire production and assembly of the unit. There goes the wall cabinet that holds the additional operating parts, extra coils, tuning units, condensers. And here's the bench that contains the tools and spare parts, a radio man's hope chest. And this is what it looks like when the operators step in. At the far end, the transmitter with the antenna tuner on top of it. On the right, the wall cabinet. On the floor, the long bench for the operators. Both of these are storehouses for parts and accessories. On the left wall of the truck, the operator's table with two receivers, speech amplifier, control panel, and below, an electric heater and the two field telephones. There goes the SCR-299 out into the field to make its final test on the air. There's just one thing missing. Where's the power coming from? The Signal Corps provides for that in a portable gasoline-driven generator that rides in this trailer behind each truck. This generator supplies standard lighting current, 117 volts AC. A transmitter and receiver that operate on this current can be hooked in to power almost anywhere. Here is the mobile power supply. A remote control from the truck to the generator makes it possible to start and stop the generator at will. The operator prepares for the air test. His first call is to Central Control Station.
WXYK, WXYK-4, calling for a check on the quality of this transmission and standing by.
And here is communication going off to war. Over these ramps roll hundreds of units that will carry the voice of victory to every corner of the earth. Like the champion thoroughbred it is, the SCR-299 rates a whole boxcar to itself. This Signal Corps unit is built for action and to get into action fast. It's a highly mobile radio station and may be set up almost anywhere in battle or invasion activities. Speed is vital. Every minute counts. The enemy doesn't wait. Communications must be ready at all times. It may be the only contact over which a blow-by-blow report flashes from the local front to the remote commands at Cairo, London, Sydney. The SCR-299 in this position is the nerve center of all our attacking forces. Artillery, tanks, infantry, Air Force, many of which are widely separated. Through the transmitter flow the reports, information, timing, and the order to advance. This is the voice of victory. Contact may be made with an approaching flight of bombers while they're still hundreds of miles away from the target. To coordinate their attack perfectly, these flyers must know the present position of our own tanks, infantry, artillery. They get this information by contact with the message center, which speaks and listens through the SCR-299. Tanks moving into position must be kept informed of the approaching air support. Timing is vital. And the timing of all these movements is controlled through this voice by direct contact with the Armored Forces headquarters. From many small stations scattered miles apart along the battlefronts comes the flash news, the observations, the unexpected, all clearing through this central station. That's how radio helps to time these big movements, make them strike most effectively and with the minimum loss of American lives. Radio communication units are among the first pieces of equipment to go into action, whether the attack is on land or sea. Radio communications stay in the fight as long as there are men, guns, ships, and tanks on the move. For the life, death, or victory of all of them depend upon this command: get the message through. Perhaps one of the most important messages ever issued is the one you're about to hear from Major General Harry C. Ingalls, Chief Signal Officer of the United States Army. General Ingalls.
I'm speaking now as one American soldier to another, for we in the armed forces regard each of you men and women in this audience as being one of us and working shoulder to shoulder with us. You and you alone are responsible for the production and performance of this vital piece of communication equipment. You have seen enough to know what good communication equipment means to the men out there and what it means to victory. You have done a splendid job. Keep up the good work you have been doing. We are asking millions of American soldiers to stake their lives on breaking Germany and Japan. They ask you to keep up your production to the limit of your ability and the high standards of workmanship that have given us an advantage over the enemy that can be measured only on the day of final victory.